So we have to learn about other microcontroller peripheral devices system. Okay, the one such peripheral device is LCD. So LCD is nothing but LCD is a small liquid crystal display. It is capable of showing one or few lines of text. They are commonly used in front of the panels of appliances such as cash register, laser. We know. So here you have to understand that to understand this, the detailed explanation of that particular slide is given here. That is, LCD is nothing but it is a display, okay, that can contain some text, some symbols, some numbers and all. Some small piece of information it will contain. When you're going to supermarket, in the cash register you can see the total price through a display. Such displays are known as LCD display, okay. And other examples are elevator. In elevator, to show the floor number, there is one display. These types of displays are LCD display. In printer, there is one display to show ready or paper is done. Such display is the laser display. Then fax machines also to show the status, there is one display. Old ATM machine to show instruction, it uses a display like that. So these are the example of LCD. So this is just a small liquid crystal display, okay. It is a small liquid crystal display, and what it do now, it has to communicate with the microcontroller. How does it communicate with the microcontroller? Using SPI, which we have already learned SPI what it is, and it can also communicate parallelly, like how it can connect to MCU. How these LCDs connected to microcontroller unit is what we are discussing here through SPI. And also there is parallel, that is many wires fast. Parallel is also there. Then RS-232 is what? RS-232 is an old serial standard. So these are the different ways in which you can connect this LCD to our microcontroller unit. This is about LCD, okay. So it is a crystal, like liquid crystal display, small liquid crystal display, which is showing these information. These are where you can see it, the applications, and how you can connect to a microcontroller unit in parallel RS-232 and SPI. Fun. Now we are going to talk about VGA monitor. VGA monitor is like the video graphic array, okay. It is more flexible to display option is to drive a computer monitor. Now VGA is a video graphic array monitor, okay. It was introduced in 1987 by IBM, okay. Now it has resolution of 640 to 480 pixel resolution is there, and it is using this cathode ray tube, and also a 15-pin connector is also there in it. And here if you see in VGA, that is video graphics array, there is this analog voltage is used, signal, there is one signal, that is analog voltage, which is used for color. So if you see VGA, video graphics array, it is introduced in 1987 by IBM. Its resolution is 640 to 480 pixel, cross 480 pixel. Now there are 15 pins which is used as a connector. Now analog signals, and signal is analog voltage, which is why we are using analog voltage for colors. Now I told you it is using a cathode ray tube. What do we mean by cathode ray tube? Cathode ray tube is an old bulky computer monitors. That is, here there is an electron gun inside this cathode ray tube. This electron gun would give some beams that would hit the screen and it will glow. So here when we are talking about CRT, in a cathode ray tube an electron gun is there that would be scanning. Now here electron gun, what it does, cathode ray tube would scan each of this text from left to right and existing fluorescent material to display an image. So it can scan across the screen from left to right existing exciting fluorescent material to display an image. When it after scanning, it would excite some fluorescent material to show the image. Now let's see how in the cathode ray tube colors are coming. So here we are understanding that it is actually scanning. The electron gun scans like reading book. Total 480 lines are there. These lines starting, it will go back again to the next line, like that. This is how it is scanning each line. One line it scans till the end, then it will go to the start of the next line, right? Then it will scan that, like that. It is how 480 lines is scanning here. So this cathode ray tube is going to scan each of this line. Fine. Now how it is colors is showing in this CRT. it will emit some, we told you, excite some fluorescent material to display an image. Now how to show color? There is a red beam that is mixed with this red phosphor to get the red color. Green beam mixed with green phosphor to get green color, and blue beam is having also blue phosphorism. Now if we mix any of these colors, we get, by mixing these three different colors, we can get any color. See, mixing strong red and no green, no blue, you get red pixel. Strong red, strong green and no blue, you get yellow pixel, like that. If I am mixing all of them equally, I get white pixel. If nothing is there, then no colors are there, no red beam, no green beam, no blue beam, means I get black pixel. So this is how I can see colors in my CRT2. Now we have to understand there is horizontal blanking and vertical blanking. You know, one line is read, it has to go to the next line's starting position, so that after scanning one line, it has to jump to the start of the next line. So our gun would turn off and it will show this horizontal blanking, leaves a bright line across the screen. Now vertical blanking means after scanning all of the 480 line is there, that is I will scan all of them. Now I have to read again from the start. So I have to go again to the top left part, right? So a diagonal line, bright diagonal line, the gun would turns off again, otherwise it would leave a bright diagonal line. So what happening in the scanning sequence, this is the scanning sequence here. Line 1 we will read, then to read line 2 horizontal blanking, because we have to go to the start of the line 2, again horizontal blanking, like that. After finishing all the lines, it has to go back to again line 1, and this is getting repeats in 60 to 75 times per second. It is getting repeat, because if this, then it will go to our vertical blank, then it will go to our line 1. And you can see here I am writing, it is repeating 60 to 75 times per second. Then only we can see this, the scanned things. If you want to see it clearly without flickering, this has to repeat 60 to 75 times per second. If it is below 60 Hertz, you can't see it. There would be an annoying flickering there in that screen. Fine. So this has to be repeated. This scanning has to be repeated 60 to 75 times. In 1 second, this would repeat 60 to 75 times. Then only we can clearly see. Our eyes can clearly see it. Understood? Now there is modern LCD and old CRT. Electron gun is used. In modern LCD, no electron gun is used. It is a heavy and bulky, but modern LCD is thin and light. Needs scanning, but here pixels switch directly. There is no need of scanning. Pixels are used here. Here also VGA timing is used. Here also VGA timing is used because of the compatibility, for compatibility purpose. Fine. So here also in our PDF there was a small difference between the old CRT and this LCD, right? So this difference is what I have given here. That is, old CRT is like electron gun is used, it is very bulky, we told, and it needs what? We are scanning here, right? We are basically scanning here, and we are using VGA timing. Now we have used here the VGA timing, right? So VGA timing here you can see it is also used in this modern LCD also. VGA timing is used. So that cannot be included as a difference. Here the other three part, here CRT scanning is there, but in LCD there is no scanning. In LCD what is there? Not scanning. Here in LCD we have pixel switch is happening directly. Pixel switch is happening directly and not scanning. Okay. So this is the difference between the CRT and LCD. Fine. Next device is this Bluetooth wireless communication. Many standards are now available for wireless communication, include this Wi-Fi, Zigbee and Bluetooth. So these are the different standards which are available now for wireless communication. Now here if you see, BlueSmurf is easy to use Bluetooth wireless interface that can be used instead of serial cable. Instead of serial cable, wireless communication, we have easy to use Bluetooth interface. Bluetooth wireless interface. One such example is BlueSmurf. Bluetooth is a wireless standard initially developed by Ericsson in 1994 for low-powered moderate speed communication over the distance of 5 to 100 meters depending on the transmitter's power line. It is commonly used to connect an earpiece to a telephone or a keyboard to a computer. So we can understand Bluetooth in much more detail. Wireless communication. What is Bluetooth? We know Bluetooth is a wireless standard for short range communication. This Bluetooth is developed by Ericsson and the range is 500 to 100 meter depend on the power level. The speed is moderate, power low, battery friendly. Power is actually low. We need to always charge. We know Bluetooth devices we always charge, right? So it's a wireless communication, short range. It is about 5 to 100 meters, that would be its range. So power is basically low. It is developed by Ericsson and speed is moderate, where you can use in the phone, laptop and or in the earpiece, right? Laptop, keyboard, wireless keyboard is the printer, wireless printer is the computer, mouse, wireless mouse is the, right? These are the different Bluetooth devices which is there. Now BlueSmurf for microcontrollers. BlueSmurf is a Bluetooth module which is easy to use with microcontrollers. Works exactly like a serial cable. It works like a serial cable itself, like connecting PCU with PC. Like with cable I can connect a microcontroller unit with PC using a wire, but BlueSmurf helps us to connect this microcontroller unit with PC wireless. And it uses how it can communicate with microcontroller unit. It uses what? UART communication. Okay, so BlueSmurf, if you see, BlueSmurf is a Bluetooth module. Okay, so that is what it is written here. It is a easy to use Bluetooth wireless cable that can be used instead of our serial cable. Instead of serial cable, we can use this BlueSmurf. So it is a easy to use Bluetooth module that is used in the place of this wire cable. Microcontroller unit PC, if I wanted a wireless connection, I use this BlueSmurf. The communication here uses UART, and here we have seen that it is a Bluetooth module. Fine. Now let's see Bluetooth versus Wi-Fi versus Zigbee. Let's see the difference between them. Bluetooth, if you see, it's 5 to 100 meter range. Bluetooth would be, the speed is moderate, power is low. Example is earphones and keyboards. We know them. Now Wi-Fi is little more larger range. We know in our house central Wi-Fi connected will be reached in most of the house areas, right? So 50 to 100 meter it will be reached. Speed is faster. Power used here is very high. Use case is internet for streaming purpose, and Zigbee is 10 to 100 meter. Its speed is low and it is very low. For IoT sensors and for smart homes we are using Zigbee. Okay, so you have to understand the small difference between Bluetooth in the perspective of range, speed, power, use case. These are the 4 things you can differ them with. Okay, range we have said Bluetooth range is 5 to 100 meter. Wi-Fi is 50 to 100 meter. Okay, Bluetooth range also, Wi-Fi's range also. Then we have to know Zigbee's range, 10 to 100 meter. Fine. Now speed. Then we were talking about the speed. Faster is what? Faster is Wi-Fi. Slow. Bluetooth is actually having a moderate speed, and slow is Zigbee. We know Bluetooth has a moderate speed. We all know that. Now Wi-Fi, if you can say, it is fast. Zigbee is the slow one here. Power is low for Bluetooth, but Wi-Fi requires high power. We are continuously connecting it with the power connection. Zigbee also uses very low power. The use case, we know where we are using Bluetooth, where we are using Wi-Fi for internet purpose, streaming purpose. Zigbee is used in our IoT sensors and smart home. Fine. So the power used in Zigbee is very low, and the speed is also very slow. That is the thing that you have to understand. Speed is also very slow. So this is the difference between Bluetooth, Wi-Fi and Zigbee. Now next device we are going to talk about is this is called as the motor control. Then we have next device as servo motor. Motor control, that is, motor control means, here if you see motor control, there are 3 types of motor, 3 motor types: DC motor, servo motor and stepper motor. DC motor means it is spinning continuously, like fan, wheels, drill and all. Now servo motor means it is moving to an exact angle. Robot's arm, there is an exact angle it can basically move. Stepper motor means moved in fixed step. 3D printer, see that is 3D printer, we know there are different steps in movement. Moves in a fixed step is 3D printer. So you have to understand that there are three types of motor: DC motor, servo motor, and stepper motor. So DC motor is something which is going to spin continuously every time, like fan, wheels and the drills. Fine. Servo motor is moving in a particular angle, like robot's arm. Stepper motor is something which is moving in a fixed steps are there, that is 3D printing is one example of that. So DC motor is the simplest motor, spins when you give it power, spins faster with more voltage. So that is what we know. Fan, consider fan, if you are giving it power it will spin continuously, right? So it is very simple motor. And if you give more voltage, means if my fan is moving very fast, I would say it has more voltage. If it is moving less faster, then I would say it has less voltage. So the problem here is that DC motor needs only approximately 1 ampere current. GPIO pins can only give 10 milliamperes. So it needs 1000 milliamperes needed, 10 milliampere available. So GPIO would burn out instantly. So the solution, GPIO pins can only get only approximately 10 milliamperes only GPU can give, but the DC motor need approximately 1 ampere. The GPIO pins can only give 10 milliampere only, but DC motor needs 1 milliampere. So that means if it has to become 1 milliampere, I have to give 1000 milliampere to a GPIO pin. So that means what happened, my GPIO pin would burst. So the solution to this problem here is the H-bridge. So H-bridge is a powerful driver circuit between MCU and this motor. MCU weak signal, H-bridge would amplify it and give it to the DC motor, strong current. So H-bridge is a powerful driver circuit which is there between MCU and motor. H-bridge also controls the direction. H-bridge forward means motor spins clockwise. H-bridge reverse means motor spins anti-clockwise. H-bridge stop means the motor stops. So here, what is H-bridge? H-bridge is basically used to amplify the signal, this weak signal from MCU. You have DC motor needs strong current, so that has to be amplified. This weak signal has to be amplified. So DC motor needs what? Strong current. So this signal has to be amplified here. Fine. So it's like a megaphone. Your voice is weak and the megaphone would make it loud. Like that this H-bridge actually acts. MCU gives this weak signal, it amplifies this weak signal and gives a strong current to the motor. Now this H-bridge can also use to control the direction. H-bridge forward means this our motor would spin in clockwise direction. H-bridge reverse means our motor would spin in anti-clockwise direction. H-bridge stop means the motor stop. Fine. So instead of this GPIO pins here in DC motor, we use H-bridge. Now shaft encoder. DC motor just spin. It doesn't know where it is and all. Shaft encoder is a sensor attached to the motor shaft. Counts the rotation, how many rotation, like counting how many times a wheel has turned. So shaft encoder is basically a sensor which is attached to the motor's shaft and it counts the how many rotation it actually done. So to count the number of rotation it actually made, there is a shaft encoder which is a sensor which is placed to the motor's shaft. It counts the number of rotation. So this is what shaft encoder means. So shaft encoder is nothing but it is a sensor which is attached to the motor's shaft and it counts the number of rotation, motor's shaft, and it counts what the number of rotation. Then we have servo motors. Servo motor is a motor that moves to an exact position. I told you an exact angle moving motor, a servo motor. The range is like it has a limited angle, usually 0 degree to 180. Between that there would be one position it can go, and it control PWM signal, pulse width modulation. Now servo motor is controlled by PWM signal, that is pulse width modulation. Short pulse means 0 degree is the position. Okay, medium pulse 90 degree position would be the, long pulse means 180 degree positions will be there. That is what here given. There is short pulse, medium pulse and long pulse. Now here it is actually controlled by who? PWM, pulse width modulation. That is one important thing that you have to remember. So the three important things that you have to remember about servo motor is that first, the motor moves in exact position, exact angle from 0 to 180 degree. There is short pulse, medium pulse, long pulse, 0 degree position, 90 degree position and 180 degree position pulse are there. And then also the another important thing is that the servo motor is accepting what PWM signal, that is what pulse width modulation signal, to specify their position over. So to specify the position, this servo motor is using this PWM signal, accepting this PWM signal. Now let's see. It is easy to interface because it is just PWM. Precise position control, no H bridge needed. Here, no H bridge is there, and precisely the position is controlled. It is easy to interface. Now, it is not very powerful. It cannot do continuous rotation like this. There is a limited angle range. It is not that powerful, but it is easy to interface. There is no H bridge here, right? Precise position, the position you want, that position you can control it using PWM signal, right? But it is actually limited. That is the main cons. It is not that much powerful. It is limited. But the main pros of this servo motor is that it is basically easy for us to because of PWM we can easily go to the position we need, and there is also no H bridge. Like in the DC motor there was an H bridge. Here you don't need any H bridge are there. You have to understand that they are more expensive and still need H bridge to drive the high step. No, that's fine. This is about servo motor, fine. It is not that much powerful and it does not need H bridge. This much other things that you have to understand. But servo motor. Now I told you there is stepper motor. Stepper motor is that motor that moves in a fixed step. Like I told you, 3D printing. That means in each pulse there is exact same angle. That is, one pulse is 1.8 degree. Then 200 pulse would create 360. That is 1.8 into 200. 360 degree full rotation. Each of these would have a fixed exact same angle. Each pulse would have one pulse is 1.8 means next would be 1.8 plus 1.8, that is the second pulse would be 3.6, like that. Each pulse would have the exact same angle. The step is same here. Okay, that is the thing you have to understand. The step here is same. Each pulse is having exactly same angle. The pulse, if one pulse is having 1.8, other 200 pulse means 360 degree full rotation is done in 200 pulse. So each pulse would have exact same step, exact same angle. They are moving in a fixed equal step. That is why it is used in 3D printing and all. Because here in the 3D printing, the head is moving in exact position, moves exact position. CNC machine, camera lens focus precisely on something. CNC machine cuts exact patterns. To cut exact pattern, like 3D printing, CNC and the camera's lens, these are the where these stepper motor is basically used. Okay, so the pros is that very precise position control, no encoder needs. We don't need to count the steps here, but it is very expensive and it still needs H bridge. Here also H bridge is needed, but it is slower than the DC motor. So you have to understand here is that this is actually kind of expensive. Okay, here the main pros is that you can easily find precisely, you can find the correct position. Very precise position control is there, and we don't need no encounter. We doesn't require here encounter. We don't need to count the steps because we know the position. Because each step has exact same angle means we know the position. We don't need an encounter to count how many steps it has got. We don't need that, and we can make it precisely calculate the position. Now the problem here is that it is very expensive and it still needs an H bridge. Okay, it still needs an H bridge here, but it is also slower than the DC motor. DC motor is spinning very fast. It is slower than the DC motor. So this is its cons. Fine. So this is about our other microcontroller peripheral devices. So this is about the module 4. In this video we will end our module 4. Thank you.